Good morning, everybody. I hope you're all well. Great to have you guys on this presentation. I quite enjoy giving this one for reasons that I'll explain kind of later. But just by way of a quick kind of 10-20 seconds on Mesh Energy. We're an independent and holistic consultancy. We're based down in the south of the UK, but do projects across the UK, Europe, States, and increasingly further afield than that. And really what we're trying to do is work with clients, work with architects, work with wider kind of design community to make sure that simply sustainable projects become more successful, and that we all really kind of get behind this and can drive some great kind of low carbon projects through. Can help at any REBA stage. And always would invite you to get in contact with us if you've got a project you think we could help on. So, as Simon said, we're talking about kind of common pitfalls here. And funnily enough, when we were prepping this, I had a look at it, and always you're trying to look for updates and new things you could drop in there. Honestly, people are still making all the same mistakes, and so there's very little to update. It obviously means I've got to give a few more of these CPD sessions, but fundamentally, I think people are becoming more and more aware of the extra thinking and the extra complexity that goes into sustainable projects. As building design gets more intelligent, we're using less rules of thumb. We're actually doing some proper analytics and heat loss studies and services design. To the uninitiated, but because of the added complexity, what's not always obvious is you can, as the picture suggests, be stood in the middle of a minefield and you don't quite know that yet. For people who have done sustainable projects and been caught out either on your own kind of domestically or on behalf of client or working with other teams or heard about other stuff, there's all manner of things that can go wrong. And without wanting to kind of scare you guys off, being prepared for these kinds of things and knowing what has gone wrong with other projects means that you're just better prepared. So what the point of this CPD session is really just to make you aware, remind you that these keep getting made, and if you can do your own little bit to just do a bit more due diligence, then that's going to help you out and create more successful projects. So probably to really understand the kind of the shades of grey and the kind of the gravitas that some of this stuff has, if we do get it wrong and we start taking missteps, it's worth understanding the results and implications of not putting enough effort in here. And all of these I've seen, sadly, all of these things that I've seen, and none of us want to find ourselves in this situation. But for the client, or for the end user, for you potentially, if you put a system into your home, there's the risk, because we're electrifying buildings with a lot of these technologies. Electricity is more expensive than it's ever been in the UK, far more expensive than gas. So if you get it wrong, you can end up with very, very, very high running costs, which is complete flip side of what you're trying to do. You're trying to design a low running cost building, but you might end up, just through naivety or just pig-headedness, not asking the right design advice, end up with very, very high running cost homes, and people have ended up in that situation. Just not being fully comfortable all year round. Again, we would like to think that when we work on a home, we're increasing our level of year-round seasonal comfort. And it can be the case that if we don't do that, we don't end up meeting that fairly basic criteria. Either buildings get too hot in the summer, less so they get too cold in winter, but it still does happen. But overheating, we hear a lot more about overheating, and that's one of the risks that's bubbling up and really stinging people. So they spent a lot of money on a project, but they haven't properly looked at the overheating risk. Just general frustration. When stuff goes wrong, we get frustrated, we get angry, we lose faith in people we've trusted, or a design methodology, or installers, or whatever it's going to be, and that's never nice to see from a client. We're all in this to do a kind of a great job, and of course, worst case is a client could actually take legal action against you. If you're a professional designer and you're part of a professional design team and you haven't done your due diligence, I've seen legal action being taken against individuals as well. That is extremely rare, but it's all hanging over us as a result of professionals, and that's why we have insurance. From a design team's point of view, just embarrassing, right? We're trying to be professionals here, so to drop a clanger in an area we should know better about, at least is embarrassing. We sometimes lose faith in our own ability. Not everybody's built the same way, and some people who are just kind of dipping a toe in it can really get stung and lose faith in their own ability. Of course, there's increased project risk. People are spending money. Some people quite quickly, the cost can escalate for large scale domestic and certainly commercial projects. So the project risk really runs high if you're not making the right design decisions along the way. And of course, and none of us want this, kind of damage to our reputations. We spend every single day trying to build our brands, trying to build our reputations so that we can win the next client. And so having that really damaged in a small or a big way, particularly if we're promoting the fact that we're doing sustainability, is not a good thing. As many houses are getting built, it's still a fairly small kind of sector, and you're never that many steps away from everybody else in the market. So the last thing we want to do is damage our own reputations as design teams. And the other thing to bear in mind here is when you make a mistake, knowing or unknowing, it can have delayed effects on the project. So often when you're in the kind of conceptual design stage, developed design stage, even the detailed design stage, because nothing's really happened on site, a lot can be covered up with paperwork, with just not knowing, because you haven't actually broken ground. So that's usually, as we all know, that's when the client's happiest, all the teams are getting on really well, and everything's been promised, and we're meeting deadlines, and tick. And then when things get a bit more serious, more money's having to be spent, there's more people involved, things can start getting a bit strained. But if we don't do or spot some of these pitfalls really before we start building, and I've put here a kind of a point of no return, and it kind of is that the costs escalate very rapidly. When you get to the build stage, very quickly, you figure out that there's an issue. And worst of all is when all the work's done, the client's moved into the home, and all of a sudden something's really kind of seriously gone wrong. Some of the things that I'm going to be talking about affect the budget as you're doing planning and early stages of the build, and other stuff you just won't figure out until the end of the project, if you bury your head in the sand here. So you've really got to get on it early on in the project and try and spot these things, or ask the right questions to really minimize risk as the project progresses. And I've talked about this before, these kind of 5 key links to any project. And we've got the strategy, what was the game plan here, the way that you're specifying the project, the installers, the guys you're getting to do the work, how you're detailing construction and actually getting that done, getting it done on site, and then the commissioning. A failure in any one of these links will break the chain. So you could do a great job of the first 4 and screw up the last one, and the result be maybe not quite as catastrophic, because you can go back and recommission systems. It's still going to particularly give you high running costs, or other issues. But any one of these links has its own very important point, and some will cost you more than others, and some can be undone, but they are all very important in their own right. So what I'm about to run through with you touches on all of these elements or links in the chain. So kind of the 7 most common and costly pitfalls I came up with it was kind of skimping on early stage strategy, not focusing on fabric. I've talked about people thinking fabric design is dishwater dull. Well, maybe so, but it can cost you a vast amount of money if you don't take it seriously. And increasingly, you're not even going to be compliant with building regulations. So there's a big stick poking you out the backside to at least take fabric seriously, even for those who didn't used to. Not properly specifying and getting a tender specification out there when you're going for work, not picking installers properly, going for one your mate said was great down the pub, doesn't really kind of cut it anymore. Not paying attention to construction detail, both planned and actual delivered on site, and poor systems commissioning. And then there's a bonus one that we've got in here, which I'll show at the end, which again it can be a ferociously costly misstep if you fall down that hole. So as far as early stage energy strategy planning is concerning, why do people not do it? Why has this come up as something that I think is a big pitfall, or something that's kind of the top of my list? Well, the point is that for many years, every project's trying to save costs. Nobody wants to waste money. Everybody wants to make sure their pound goes as far as possible. And I just don't think, I think people think, and I say it is less so, but there's still a fair amount of people who are still trying to save costs. They just don't see the point of planning. They think they can rely on installers to give them kind of the right advice, and if they explain it in the right way, then the installer is magically going to know everything that they need to know and be honest and pick the right product for them. So there's a bit of kind of inexperience and not really understanding the risk of doing a proper strategy plan at the start, and that could be figuring out how you're going to insulate the building, a building services strategy, what you're trying to get out of it as far as running costs, whether you're trying to future-proof it for like 5 or 10 years down the line as technology changes, whatever it's going to be. A lot of those risks are unknown, and still a big one when people get excited and they get all their architectural plans together is, right, when can we start building? And so they're rushing to get sort of groundworks contractors out. They've got all their planning permissions and stuff. And again, the focus is in the wrong area. The focus is on breaking ground. You know, we need to build this in a year's time so we can move in for Christmas. We've all heard that. And they skip some of these important points and hope that contractors can kind of figure it out for them, or the MEP designer that they've got on board, you know, whatever it is. And there's also, we see bias from installers, but just knowledgeable friends and family members. We've all got great networks, and we all trust people in our family. Most of us trust people in our family. We trust other people in the construction industry. We trust people we've known for ages. And everybody's keen to give a recommendation. Nobody wants to, be asked a question in the area of kind of general area of their knowledge and then not kind of have an answer. And sometimes I think we can get sucked into this funnel of, oh, such and such said this, so it's kind of taken as read without kind of doing our own due diligence there. Just because their project's been successful doesn't mean that your project's going to be successful. Every single project is completely unique. They'll have different things that they were after. So sometimes just people getting sucked in, and this is cheap, getting recommendations from mates. That's why people do it and don't think that they need to spend money on getting proper kind of due diligence done on the energy strategy. But the risks are you just end up with a suboptimal solution, one that doesn't fit your needs. You're not thrashing out all the detail, so some pretty big question marks, which could be critical. They might not. They might. You find that out kind of far too late when it's more costly, and you just end up with kind of a complicated end result. There's a good reason why we plan stuff, and that's usually to make sure it's simpler, it's easier, it's more efficient. And the same goes with homes or more complicated buildings. What we're trying to do is make sure that with a bit of thinking up front, you end up with a really elegant solution further on down the line. I mean, how many people who are, I don't know, designing a race car or the iPhone, or, how many just went at it and didn't kind of think about the right design and what might be a good point to start and some of the risks if they went down particular design paths. And the same is true here. But as I alluded to in the first kind of graphic at the start, if we pushed some of these decisions down the line, they just get more and more expensive. As a project progresses, every single project gets more and more expensive. There are more people involved, orders have been placed, plans have been drawn up, and it just exponentially gets more and more expensive. So if you miss a critical part at the beginning, it can cost you an order of magnitude or more to fix it later on down the line. So there are some risks here in doing it. But the benefits, funny enough, are getting an elegant solution. They're the inverse of the risks. You can be more confident. We found people who are better planning energy strategy, it binds the team together and they can ask the questions and they feel as if it's a more thought out, robust solution. And then they can confidently progress knowing that they kind of know a lot of the answers and they know why they've gone a particular route. It just means that there's plenty in construction projects that taking your effort and mind and kind of brain capacity. So think about those. You don't want to be thinking about, oh, have I made the right decision here? Have I made the right decision there? It's just a kind of a foundation confidence builder. So get energy strategy planning done early. Get some independent advice. Of course, I would say that. But you need to consider things like, what's your budget? What are you actually trying to achieve with the project? Available services, and you need to understand how they interact and whether one jeopardizes the other. I think increasingly when we do energy strategy planning, it gets clients doing some solid thinking about actually what success means for their project and what the end goal is. Increasingly, there are various sustainability frameworks that people might want to hit. Commercially, of course, there's kind of BREEAM and more kind of sophisticated things that you can choose to do or are forced to do. But particularly from a domestic point of view, getting a better understanding of kind of client goals is really, really key. And you can make sure financially you understand the implications of what you're doing as well. Pitfall number 2 is about fabric. As I say, there's been a huge amount of focus on this over the last few years, and rightly so, because if you've ever seen our kind of energy hierarchy, fabric design is right up there at the top. And yes, it's boring. Yes, you're sinking money into something passive that you just end up wallpapering and painting over, so you never really kind of see it. But it guarantees you lower running costs for the lifetime of the home, regardless of what fuel prices are doing. It's all relative, right? You could spend less on the fabric and spend more money on a kitchen and pay more for your running costs. Fine, if that's what you want to do, then happy days, and you kind of go at it. And there's a number of people that do. But increasingly, regulations are, as I say, it's a sharper stick from the back end, making sure that this is focused on. But why historically have we not looked at fabric? Well, we're creatures of habit. And when I say this, I mean architects generally are creatures of habit. We've got our kind of details of wall constructions that we've used for years and years and years and years. We might have tweaked them a bit, we might have a few varieties, but we know a number of architects who, when they approach a domestic project, they're like, oh, right, yeah, that's what we do for the walls. That's what we do for the roof. That's what we do for the floor. And these are constructions which are probably just scraping by building regs, because it's saving them time and money. Why reinvent the wheel? Why, go through figuring out U-value calculations and psi-value calculations, all these other kinds of things? Why not stick with what you know? So we're all creatures of habit. We want an easier life, and professionally, I know that still happens. I'm sure there are plenty of people that doesn't happen for, but I can tell you there's a lot of architects who we speak to who have done that, and now they appreciate that they need to kind of up their game to make sure that that the U values are getting lower and lower and lower, and thermal performance is getting better and better and better, and they're keeping up to date with what's needed to be done. I think also when the fabric of a building, when you're talking about putting more money into insulation of a building, let's double the amount of Celotex we're putting in the building. Let's double the amount of sheep's wool. Let's make this wall another 50 millimeters thicker. Who knows what difference that makes? Very few people. They just see another 10 grand spent on Celotex for their project, and they're thinking, why do I need that? I've already got 100 millimeters in, so why do I need 150 millimeters of insulation? Or why would I spend £10,000 to make my living room smaller? And they don't fully appreciate that adding that extra bit of Celotex might be, as I say, reducing their running costs by 25% for the lifetime of the building, compound. So I think a better understanding of what material costs, what those build-ups, what difference that makes as far as the overall peak heat loss and running costs, I think is where we've seen a lot more enlightenment. But historically, that's why it hasn't been done, because people can't correlate buying more building supplies to it's going to be cheaper for me to live in the building. And it's just been a complete guess as to what that relationship is. So the risks are high running costs now and in the future. So if you scrape by building regs, you do what you carry on doing, even if it's compliant, you're going to end up with high running costs. So of course, that kind of makes sense. The better you insulate the building, the lower your running costs are going to be. But if you don't focus on fabric and you want to spend your money in other areas, your running costs will be higher. Even if you spend it on a fancy doody gold-plated kind of heat pump or solar panels, your running costs are likely still to be higher. It also reduces your choice of technologies. as we better insulate buildings, the energy that the building uses is less, which means if you kind of extrapolate that, you can have bigger homes that use smaller equipment in there, and every heat pump and technology has its kind of limits before you either need to put another one in there, or you simply can't use it, or the running cost, the flow temperatures and stuff need to be too high for the room volume, whatever it's going to be. Essentially it reduces your choices. So you're cutting out your choices by skimping on the fabric efficiency of the building. You've got increased costs of ventilation and heating, as I've said, but also the knock-on on all of this is a poor SAP rating. You know, building fabric now and airtightness has a huge impact on your EPC rating at the end of the project. And there are increasing links with EPC ratings and building value. So potentially you're knocking value off of your house by not spending it on the way that you're insulating it in the start. And you know, that's a financial risk, as well as a risk on the kind of the running cost side. But that's still, you know, still up for discussion. So the benefits, of course, are reducing your running costs. And the other thing to consider here as well is if the complexity or the size and the complexity of the heating system or ventilation system that you're putting in is smaller and potentially simpler. You know, ducting can be smaller, pipe work can be smaller. If you're not moving so much heat and energy around the building, then you get higher ceiling heights, you get smaller voids. You know, you haven't got to spend money in other areas if you spend money on the fabric, because all of these things are interrelated. So what I would suggest here is making it a really high priority for the design team. Get an early stage heat loss done. The heat loss calculations now are so cheap, relatively speaking. You can find out, you can play around with, if I better insulate the house, I spend this much money, how much are my running costs affected? And just understand how that affects services. That's all about early stage kind of question asking and analysis. And that, of course, you know, you're going to need to do really before you kind of go in for planning. You know, really it's in the develop design stage that you're getting these things nailed down. So understand the numbers, understand the implications of spending more money on fabric and what that means. You may still decide not to do it, fine, but at least you understand the implications. And this little story just picks up on that. So I've called this the air con, and you'll see why. So we did a building a couple of years ago for an architect. They just went for building regs U values. They went for what they knew. They had this massive floor to ceiling 2-story atrium, glass atrium in this house. Did no overheating analysis. Just went for building regs U values, and weren't the slightest bit interested in having a look at solar shading. How is this thing going to cope in summer, and just using kind of passive measures really to make sure that it wasn't overheating. And they decided, and because the client was from a foreign country, they were used to air conditioning, they were just going to solve the problem of their home with air conditioning. So we're going to be lazy with the design, and they're going to solve the problem with a mechanical air conditioning system. It was very expensive. They needed to upgrade to 3-phase electricity to get the air conditioning system in. They were having heat pumps, big tick, but the aircon system tipped it over into 3-phase. So they needed 100 amps 3-phase to this property. Spent 15 grand getting 3-phase to the property. They spent 65 grand on hidden aircon, really like it wasn't like a hotel room, bolt a unit above the door, and, you know, as a proper professional kind of aircon system. They spent 65 grand on that. They added another £400 a year just to keep the building cool during the summer. And the 10-year cost, forget the 3-phase electricity, the 10-year cost was 70K. And then that aircon system, or the aircon system at some point, is going to break down, right? So you're going to need a new aircon unit outside. Of course, all the ducting stays, but, you know, they're still going to be stuck with £400 a year, probably rising if electricity gets more expensive. Yes, they've got a bit of solar, but this is the impact. This is what I'm telling you. You imagine how much insulation they would have got for £70,000. You know, I can tell you a heat loss study and an overheating study would have been a lot cheaper. And this is what we're talking about. People who seem obsessed by money and saving money on certain parts of their project are just blind to the implications of saving money in one little area. You could have spent £10,000 on insulation and significantly reduced this. And I believe they could have taken aircon out of the building entirely. So you could have done, that's a kitchen and a half, £70,000. So anyway, that's what they decided to do. And that was the implication. Pitfall number 3 is about insufficient tender specification. So we've developed the design, we've got it through planning, and now it's about detailed specification, going out to tender for installers. So why is this not done? Well, again, historically, I've seen MEP contractors just put on a spec document, heat pump is needed, like essentially like a heat pump is needed, and that's about it. At like detailed design stage, they've got a rectangle in the plant room and a circle for the hot water cylinder. And that's really it. They don't really understand that heat pumps and some of this other new renewable technology needs more TLC. It is more complicated than just oil and gas boilers. You need to do some proper specifications. So whoever you're going out to has a proper kind of framework for which they're doing quotes for, and ideally some kind of suggested brands. There are good brands, there are not so good brands. Where does the client sit in there? A lot of trust is put in product installers, so people skip the detailed design phase for heat pumps and they just go, oh yeah, my mate XYZ Renewables, he knows what I want. That's a 50 kilowatt heat pump in my house. Yeah, maybe not, but you've trusted your installer, so funnily enough you're going to get a quote for a 50 kilowatt ground source heat pump. Whether or not you needed a 35 kilowatt heat pump isn't really the point. You've put trust in him and you're hoping that he's selling you the right thing. And of course, an attempt to save money. Chopping these things out is always an attempt to save money, and it's a fallacy, as I've said in most cases. So the risks are you're just not clear about what's needed. You end up with a suboptimal solution because it's not properly considered, and then the installer's just trying to shift something that they've got the highest profit margin on. But one of the biggest risks here is a huge variation in tender return prices. So we've seen variation on return prices where a proper specification hasn't been done of 100%. So the right price might be 30, but I've seen quotes from, I don't know, 20 to 40 or 25 to 50 or 30 to 60. I mean, it's been that's a small example. I've seen wider variation than that. But because you don't know exactly what you need, how do you know if the low one's right? How do you know if the high one's right? How do you know if none of them are right? And that's the risk. So again, there's an opportunity for wasting money there. But even, we go cheap. How many times have we gone out to tender? We've gone for the cheap tender, and all of a sudden you figure out they've missed 20% of the spec, and so there's extras that get bolted on at the end because the spec hasn't been properly written. That gets more and more aggressive and extreme as you get into particularly like ground source heat pumps and stuff. They're not cheap things, generally speaking, and the extras are not small amounts of money. So that's a real again a financial risk there. And just certainty. Wouldn't you want 3 return tenders in a pretty tight cluster and knowing that you've done the due diligence there? So that's the risk as far as tender specification goes. So the benefits of getting it right are simply clarity and making sure you're getting value for money. So I mean, top tip here is don't just go straight to installers. Do something. I mean, do something. Don't just rely on installers doing kind of fag packet calculations for what they think that you need. Even if they do the heat loss study right, they don't really understand how that's working with the ventilation system, where that system truly sits in the overall ecosystem of the building. And just make sure you've got some basic drawings. More information helps. You haven't got to spend big money unless you really want to. Some people do, some people don't, but do something as far as the specification and get that checked if at all possible to make sure that it kind of hangs together. Don't just pick up the phone, skip stage 4 and hope everything's going to be okay. We see that far less on bigger projects, but even small domestic projects where budgets are really, really important. That there's just as much money to waste in. It's all relative. Installer choice, pitfall number 4. This is again down to just confusion as to where to look. there's a scheme in the UK called the Microgeneration Certification Scheme. That's installers who get certified to a certain level, and it used to be necessary to get government grants, and in fact I think it is still necessary to get the boiler upgrade scheme grant. But when the RHI was about, that was a way of kind of separating the wheat from the chaff, and you had to be certified on the MCS scheme. But how many people know to go? There's a database where you can search for accredited installers. Not that many people, sadly. Not that the Yellow Pages is around anymore, but how many people type in ground source heat pump, air source heat pump installer near me into Google and then call the first few people that come up? But there's no real way, again, unless you ask for recommendations, of figuring out who's good, what's their credit history like. There are more and more companies popping up now because the renewable conversation is getting stronger. And some of those companies will have disappeared in 6 months' time and have taken people's money, just like they did do with solar PV and that kind of thing. So it's done because, again, people want a quick result. I don't want to go so far as to say lazy, but as humans, we're all pretty lazy, want an easy life. So if we can get there faster, we'll try and do that. And there are some really good installers out there, but there are also some really good sales people for dubious equipment. So there can be. I met a great guy, he says an air source heat pump's the best thing to do, and I believe he can do it. So people have gone down that route, whether that's right or not. And given the sums of money that are being spent on this kind of stuff, speaking to a few, getting decent information out of them, and double, triple checking is always key before going for this. So the risks are, somebody's trying to make a sale to you based on profit rather than anything else. I know it's a bit of a kind of a negative outlook, but again, I'm just trying to be honest with you guys. You've got an increased risk of, it's a bit of a kind of a fly by night, and you want an installer with a reputation. So the worst thing is, again, you put something in that just isn't suitable. It compromises the entire building's kind of heating strategy. You get left with high heating bills, etc., etc. Those are all risks, and they're all pretty insidious. So a good salesman can cover up a lot of other issues. And so as far as how to succeed here, this is probably the most important thing. This always helps if you know the strategy that you're going for. You can speak to these guys with a lot more kind of gravitas. If you're uncertain, you'll let installers guide you with what they think is the right thing to do. Get a recommendation. Still, recommendations in these areas are still really key. We give out a number for guys that we really know. We don't get any kickbacks, but there are guys with reputations that they want to keep going. Give it time. Don't rush into this stuff. If you're going to be parting with 10, 20, 50 grand's worth of your money for a heating system, don't rush that. Make sure you speak to a few installers. Give it time. Do some checks on them if you can do, and then, like with any of these things, you're far more likely to make the right choice. Speak to previous clients of theirs. Go and see installations. It's all the usual kind of stuff. And that's how to succeed in this area still. Hopefully I'm not kind of teaching you guys to suck eggs, but it's really important just because of the sums of money involved here. And a quick kind of case study. This was, again, somebody trying to save money, a good old-fashioned builder who thought he knew better, building his own home. Full disclosure, it's not the one in the picture, but it was a lovely new home. Builder spoke to me, 3 or 4 phone conversations, got loads of free advice from me. I didn't have anything better to do, so I spoke to him, got loads of free advice from me. I'm thinking, I'm going to make a sale. I'm going to give him some installer recommendations and do a spec for him. And then it went quiet for a long, long time. So he didn't pay for any detailed advice, went away, took that information away, got some installer recommendations from somewhere, and then I think he only went to one installer, but he was happy with the price and got the installer in. The installer made a miscalculation on the heat loss of the building, and because the client didn't have anything to go on, he didn't have a spec, we hadn't done the heat loss calcs for him, he trusted the installer that was right, and the installer hadn't picked up on their issue here. So they put in a heat pump that was twice the size that was needed for this low energy home. And worse than that, it had boreholes. So it was even more expensive because they put in twice the amount of boreholes that they needed. Well, boreholes were £5,000 a pop. So, you know, the numbers were building up here. And yeah, all of that, I reckon they wasted about 20K in putting in this extra heat pumps. Not a small amount of money. And worse than that, even though you would think like a big heat pump, right, in a small energy efficient building, you would think, well, there's no extra running cost. You're not kind of doing any more work. But bigger pumps, bigger compressors, bigger units all take more energy, even though they're running at a lower kind of duty cycle. And of course, spare parts are more expensive for bigger units. You can't, like, when something breaks, you can't just like put something in that's suitable for a unit half the size. So a big kind of faux pas there. A builder trying to save a couple of grand ended up spending 20 in kind of wasted costs through poor advice. So pitfall number 5 is about detail on, you know, when you're actually on site. Hopefully you put decent detail into the design, but this is about when you actually get on site. So again, I think increasingly people magically think that sustainable buildings just like happen. Once you've done all the detailed design in the desktop, builder comes along, they get some really good kind of workmen in, and they smash together, you know, passive houses is an extreme example. I think we know the effort that goes into building a passive house, but there's still shades of grey in between. And so I think there's a big lack of understanding of the importance of detailing and making sure that detail actually ends up in the finished project. Again, you know, not intentional, but I've used the word kind of lazy workmanship here. I think because of a lack of understanding, the way that people have boshed holes through external walls or not properly, you know, foamed half bricks that they've knocked out as part of the kind of the process of putting a house together. The workmanship that we're used to in the UK construction industry is still very much carried on into this new phase of energy efficient homes, and it's just not good enough. And nobody's championing, you know, nobody on site is responsible for that level of detail. And before you know it, stuff's been covered up with plasterboard, with cork, with other kind of stuff, and you hide these issues, and depending on how often the project's being surveyed, you can quickly miss things. You know, something that happens in a day could be absolutely critical to the air tightness of the building. You just don't find out, but until you do an end of project air test. And the other one is, you know, that it hasn't been detailed correctly by the design team. So the builders are great builders; they're just doing to the detail that's been designed for. So it can work that way around as well. You could have a great team, but poor design, and that's just as bad as great design and poor execution there. As I say, these are really critical links in the chain, and they all need to hang together to come off here. So the risks are late stage modifications, money and stress. We've all been there. Oh yeah, you know, some of these, the detailing on the windows isn't right, so we've got to take all the windows back out and re-put them in properly. How much is that going to cost? Well, that might set your project back by a few weeks, and it might cost thousands of pounds to do. Who knows? That's assuming I've got to hire a crane to take the windows out that you put the windows in the first place. So modifications through construction, remember what I said about costs increasing, can be very stressful and very expensive. One of the biggest issues here is airtightness. Airtightness plays such a critical role in new buildings that, as I say, just that pipe, that 22 mil copper pipe that you've drilled a 40 mil hole through your outside wall, and it hasn't been properly foamed or sealed, or I don't know, a light fitting, or, you know, power socket, or all kinds of things that penetrate through the building or could lead to air leakage through the building. All these things build up, and if you're not on top of them, you end up with an atrocious air test result at the end. And if you're not into testing the project at key phases, you can get caught out by that, and that's just poor detailing and poor execution. Cold bridging and condensation issues, that should be obvious. Again, you would hope that would get caught out by the proper, you know, properly in the design phase. Yeah, kind of a classic is in cavity walls, where you've got you know, kind of the metal butterflies holding the skins together of a cavity wall. You know, the classic is there that you get a poor bricky and they're dropping mortar on, and then all of a sudden there's a path between the two cavity walls for condensation and stuff like that. We're talking about a more sophisticated way of cold bridging now, but it's the same kind of thing. It's just poor workmanship and not checking before stuff gets filled in and covered up. And of course, the other one is, and this is again rising rapidly, because building standards and construction standards are getting so much tighter, the risk is you fail to meet the standards at the end of the project. And that's, that means that building controls can't sign it off. You can't get the SAP results that you're after. Maybe you fail your SAP target, your airtightness target, and that takes you way away from where you need to be. I mean, non-compliance is non-compliance. Can it be fixed? I don't know, but who wants that risk at the end of a project after you spent all that time and effort? So how to succeed here? It's all about making sure that it's designed properly at the start. Find a great builder. I've said here with a motivated team, I think there's still there's still room here for a team that understands excellence in construction, making sure somebody's put in place to make sure that they're championing stuff like air tightness, and understand that just stuff's got to be done to so much better quality before you cover it up to really make sure there's no surprises at the end. Increasingly, I've seen air tightness specs put into a builder's contract. So the builder is responsible for delivering a certain air tightness value contractually. Now that's a new one for a lot of people, but why not? They're intimately involved in building this thing. So funny enough, they might take a bit more effort if they know they're not going to get paid at the end, or it's a critical part of them succeeding on the project. And I've said here just about allocating champions. This is all about making sure people are one person. Numerous people can't be responsible for stuff. One person has to champion these things, whether that's checking, whether that's various elements of the build, and can't shirk that responsibility. So a bit of this is about kind of changing process. And if you've got the right builder, they'll lean into that as well. This is another quick little kind of case study, and just aware of the time here, but really, really quickly, this was a guy who was trying to build a passive house. This was a guest accommodation on their site. They were trying to build a passive house. Well, for those of you who understand passive house, that's an air tightness value of 0.6 meters cubed per meter squared per hour. They ended up with an air tightness test of 8. So over an order of magnitude worse than the passive house target they were going for. They didn't do testing. The fitting was poor on these doors they had at the front. And that was all about detailing. They started out wanting to put an air source heat pump in. They ended up putting electric underfloor heating throughout the building. Just electric underfloor heating. No air source heat pump at all. Just electric underfloor heating. Completely blew away the vast majority of the sustainability credentials of where they wanted to get to. And what that meant was, it was worse than triple. They were going for passive house levels of air tightness, so it's an order of magnitude worse. But the building was almost non-compliant against building regs calculations. So the SAP calcs that were done, I think we scraped by just by the finest of threads, and this should have been a passive house level build. I mean, not certified, but that's what they were going for as far as kind of building principles. And we reckon this was costing about 1,600 quid a year to run, as opposed to 500 quid a year where they should have been. I mean, just a complete waste. And a lot of this was detailing. And honestly, these guys were very, very wealthy. I mean, putting in an air source heat pump as opposed to underfloor heat shouldn't even come into the conversation. But making those decisions and not staying on top of it, the team let them down, and it massively increased their costs. And how much they were paying for this guest accommodation through the year. Pitfall number 6 here is about system commissioning. You can get everything right, and the commissioning can let you down at the end. So often people forget about commissioning. Trades want to get wrapped up. They do their little bit, they sign their little form, and off they go. And a lot of buildings now are that much more complex, and you need to get a number of people together to commission their systems. And yeah, so it's just been in a project rush. That's really what it kind of comes down to. So really, you need somebody responsible for overseeing that element of the project. And the risks are high running costs. The system isn't optimized for the kind of the occupants and the way that they're using it. High running costs, shorter equipment life, because again, it's not in its sweet spot. It's probably thrashing itself, or it's working against another technology in the property. So a lot of this again comes down to cost and lack of comfort in the building. And increasingly, we're talking to clients about post-occupancy evaluation to make sure systems are commissioned properly and having oversight of, you know, those final kind of commissioning certificates. So have a commissioning plan and checklist together. Have a third party check the work if you know, particularly in a multi-system setup, and make sure you monitor electricity usage carefully in those first kind of 6 months after the guys have left site.
Doug, sorry, can I just say, I'm just conscious of time as you are, and I know you're coming to an end.
Sure.
There are a number of questions as well.
Yeah, sure. I'll do a couple of minutes, then we can
Cool.
wrap it up. This one's pretty straightforward. Really, this is just about electricity. So this is a kind of a bonus one. A lot of people forget about making sure that the electricity services to the building are right, and they can be very, very expensive. We've seen quotes from £1,500 to £150,000 for getting 3-phase electricity into a property. You don't need 3-phase for every project, but for medium and larger scale houses, certainly, if you've got a car charger, you're cooking on electricity, you've got various other things, electrification is key. So don't forget about the electrical services in the building as well. There's a few other slides, but let's get on to the questions to make sure we don't overrun.
Yeah, sure. George, did you want to come off mute and make your point or ask your question?
Yeah, sure. So yeah, it was just a question really going back to something you were talking about at the beginning of the presentation, where, you know, obviously we're eager for clients to spend more money upfront on consultancy fees, so you can kind of get a project specific sort of understanding of the relationship between improving the building fabric and then, like, you know, what the sort of knock-on effects to other costs are for that. So, you know, the sort of lifetime building costs, energy costs. But unfortunately, like, you know, that doesn't happen on a lot of projects. There's not like a client sort of intent to spend that early stage money doing that. So it's just whether you're aware of any resources for sort of rule of thumb sort of cases, any studies been done on sort of typical houses, for example, that we can use to kind of almost like back up our suggestions to clients, you know, to be improving the fabric.
I think that the simplest way that you can attack it, I mean, as I'll go back and say, I mean, to give you an idea, a kind of doing a heat loss study on a domestic property is, you know, it's kind of hundreds of pounds. It's not thousands of pounds, depending on how many variations they want to have a look at. It's you know, obviously the number gets bigger, but fundamentally what we're talking about is, if you know, for example, what, you know, the typical U value is that you might be designing a wall to or a roof to, or those kinds of things, proportionally, I mean, I don't know how many of you guys are familiar with the kind of the area weighted method. So if you've got a U value over a certain area, and obviously if you've done a basic model, you'll know what area the roof is covering, what area the walls are covering, what area the windows are covering, and those all have different U values. So as you if you can work out, and there are some U value calculators online, or it's very, very simple to figure out what the U value is of a construction. If you add a certain extra bit of insulation in, you know, to a U value, that's going to reduce your U value. If you're improving the insulation, then you can work out what the extra wall thickness is. So it's just a quick little kind of sensitivity analysis you can do almost on the back of a fag packet. So you've got your areas, your U values, and when you reduce your U value, proportionally, forget what the running costs of the building are, but proportionally you can see what the effect is of the building. Now, if you're working with a QS and they can say, well, you know, putting another 50 millimeters of Celotex in the walls and the roof might cost you, I'm just picking a number here, £5,000, then you can say, okay, well, I can spend £5,000 and my energy usage might reduce by, say you've worked out that putting a bit of extra insulation in the walls is 10% or 5% or whatever it's going to be. You can then start weighing up, do I spend £5,000 to reduce my energy bills by 10% or 20% or whatever it's going to be? And it gives you more discussion points there. Obviously, it's not going to give you any kind of finite numbers, but it gives you a flavour for the impact that you're making on the building. But I'm not aware at the moment. I mean, I'm always kind of cooking up ideas, and I would love to be able to have a simple kind of energy use tool that we could make available, you know, like a free tool. So you could just say U values this here and here. Here are the kind of the areas. It's easy to do in a spreadsheet, but it'd be quite cool to do something in a kind of a 3D kind of toolkit way. But does that help answer the question, at least, George? There are some simple ways of figuring it out.
Yeah, I think so. That helps a lot.
Thanks, George. Anna asked, do you have any tips for preventing installation errors, or is it just going to come down to the spec? I'm assuming that you mean you're in kind of stage 5, so the guys are installing equipment. You've got a specification. Is that what you mean, Anna?
Yeah. So yeah, just so you did actually mention a couple after I'd asked it, but yeah, I quite like the idea of the builder, somebody within the builder. I suppose my concern is taking responsibility for installation promises.
Yes.
You need the builder to be the person championing it. So I thought that was nice. Yeah, it was just to get ideas about how to really embed it in the specification.
I think a lot of this is around builders and installers really understanding that somebody's going to be paying attention to what they're doing. Like, I mean, you know, how many gas boilers do we know that, yeah, they'll give you a quote and they kind of hope that nobody really knows what they're doing. As long as it looks neat at the end, then they can kind of get away with getting their bill paid. There's more going on with heat pumps, and you know, if you mention it in the spec or in conversations with the client, with the contractor, that you know, we're either looking to inspect the installation or have a third party look at it, or just take more care and really care about the commissioning certificate that's going to be raised, and making sure there's going to be a bit more kind of due diligence around it. I mean, the question for the installer is how, with that in mind, how can you convince me that we're going to get that kind of level of service from you? How can we prove that, you know, we know this is going to be spot on, and you'll find the right installers will have the right answers for that.
Right, yeah.
And you'll find that the other installers will just kind of make up excuses and then kind of go a bit quiet on you. But letting these guys know that that's an important point, and the quality is really, really important from the start. We all got clients like that who really focus on the quality, and we up our game when we know clients really do care about quality. I think in part it's mentioning it, and that helps a lot.
I have had it before where it has failed the final test and everybody's been trying very hard, but somebody's made a mistake. Everybody knows what the mistake is, and it's yeah, not a great position to be in.
No, it's awful, isn't it? I mean, we've all been there, despite doing our best.
Okay, thank you.
Thanks, Anna.
Sarah's asked, would you like to ask the question, Sarah, or shall I ask it for you? I'll give you a couple of seconds to come.
Oh, no, Mike, there you go. So Simon, she just said no, Mike.
Oh, okay.
No, ask it for it.
There we go. So Sarah's asked, what's a good resource for learning about detailing for airtightness and process for achieving it as regards to testing?
Oh, good question. I'm sure there are going to be better people with resources here. I know David Lees is on the call. David might have.
In fact, David might well have answered. Yeah.
Yeah. There are, I mean, for airtightness, I mean, a really good place to start actually might be the passive house trust. Go on, David.
Can you hear me?
Yeah.
Sorry, I don't know if the camera's on. I'm being a bit rude.
That's fine.
Yeah, I've asked a really long question there that's stupid, but we just get completely frustrated. Anyway, where I've learned the most, there's a website, an American website called The Build Show. And it's brilliant. He's built a whole house going through every stage, and he goes to houses, and his slightly older videos, it's absolutely excellent. You've got to be very careful watching American sites, because when you're in California, they are air conditioned and the whole vapor movement is back to front. The condensation, so you've got to be careful where you are in America. I don't know if you understand. So that's one show, the Build Show. It's brilliant.
Was that the Build Show?
Just Google The Build Show, then it's he's like you, but he's from a building angle, and
Yeah,
it's
okay.
about construction. And he's built this whole empire. He's built this whole business now online with different people, architects contributing all these educational things. So there's the build show, and then there's oh God, what's it called? Something Fight Club, Building Fight Club. It's a funny name, but it's a woman, and it's primarily on Instagram. And she's really good on the external envelope. She's just the external envelope. Moisture, vapor barriers. But the build show is brilliant. I mean, I've learned so much.
The two that would immediately spring to my mind are speaking to the Passive House Trust, because of course passive houses, they go to the nth degree for airtightness detailing. There must be some standard construction details that they're happy to share, but also the ACB. They have they've got the kind of the ACB standard, which has, I think, an airtightness of about 1.5. So they may be able to share, again, details that they've come up with a group. The ACB is far smaller than the Passive House Trust, but those two, really hang their whole design philosophy off airtightness.
I mean, the thing about the build show, he actually they show you building it, they show you constructing it. He walks around and then he started, and he's a bit backed by products now, so you got to watch that. It's the best. There's nothing comes halfway to it.
Okay, there you go. Cheers, David.
Yeah,
thanks, David.
Cool.
Well, that's the hour, Doug. So I think we've got through a lot there. I mean, what we can do, because you mentioned that you had some slides that you didn't quite cover, so I can upload those to MESHWORK.
Yeah, we'll share the full presentation.
Yeah, so we'll share the presentation, we'll share the video. If anyone else has any questions that have come out of this, then I'm sure Doug will be happy to answer them, or we can start a thread underneath the video recording. So yeah, please do so. So thanks for everyone's contributions and engagement. It's good session. We have 3 events in November. One of them is an in-person one I mentioned in a couple of webinars. So the next one is going to be the in-person event on the 9th of November. So we have a little break of a couple of weeks or so. But no, thanks for attending. Thank you, Doug. And
cheers, guys.
Seeing you all at one of the events in November. Cheers, guys.
Thank you. Cheers. Have a good day.
Hang on, Doug, just hang on.
Yeah.
There's an Anna Williamson response there, so she must have joined you. She's the American.
No, she's Christine. It's not me.
Oh, Christine. Right, sorry, Anna. Yeah, it's Christine. Yeah, sorry.
I just saw it.
Yeah, sorry.
Cheers, guys. Bye.
Bye.
Cheers.